Hey everyone, and welcome to another Into the Terminal. Today we're going to be talking about service troubleshooting, which is something that I think a lot of us system administrators do. Um, and so we're going to be showing some practical things of commonly caused system misconfiguration. But with all of our troubleshooting episodes, we start off with kind of our toolbox of tools that we're going to use for helping diagnose and reconciling these problems. So Nate, you want to jump into the terminal and show us our tool set today?
Sure thing. All right, so over the years, I've developed a little bit of a toolbox for things I use when troubleshooting. I mean, lots of things on a RHEL system, but these were a little more specific to services. And ever since, what is it, RHEL 7, we're in a systemd world, so these tools are going to be specific to systemd. If you're looking for a non-systemd tutorial, sorry. All right, so the first tool you're going to want to care about is systemctl. Right? And if you just run it, it gives you this output. I don't know. What's this showing? It's actually showing us a whole bunch of things that systemctl or systemd knows about. Running it like this isn't quite as helpful, except it gives you a nice summary, right? If you just look through this summary, you could find the service you care about and see its status and whatnot. If you really want to see the status of a specific service, there's a subcommand called systemctl status. And you could do it on something like SSHD, because I know that's something that's already running. And it gives you this nice output. We're going to go a little deeper into this in a little bit. Another cool feature that I like about systemctl is systemctl edit. If you remember the old days of the old sysv init or system5 init, whatever, I know people can argue about what that's called, but editing the startup files for services was kind of tricky. You had this case statement that you had to like figure out where you wanted to put your customization in. Some of them were written one way, some of them were written another way, some of them were nice and modular, others were just a complete mess. Systemd really kind of helps with that. And there's a nice subcommand called systemctl edit. So if I do a systemctl edit on mariadb.service, it's going to, oh, did I typo it? Oh, I did .server instead of .service. Copy and paste, folks. It brings you this nice editor in whatever your system's default editor is. In my case, it's the only editor that matters. And you can see in the comments here, it gives you some examples of things that you can do, and it tells you exactly where you should make changes at. It also tells you where these changes are going to get stored. We're not editing the actual MariaDB service file. We're adding in what's called a drop-in, which will go in this directory you can see at the top, etc systemd system mariadb.service.d override.conf, right? So I don't have a specific thing I wanted to add to this, but we're just going to take one of the examples from down here and copy and paste it up into here. Take away the comments. And we're going to save it. And now if I look in etc systemd system mariadb.service.d, you can see there's an override.conf that in there has exactly the thing that I just added. That's a little formatted funny, but you can work on that if you're doing this for reals. Honestly, I don't actually want that there. I just want to show it to you to show you where it gets written to. We're going to get rid of that. All you have to do is delete the file. And now if I go back into systemctl edit, you'll see that it's back to the empty state that it was in. So there you go. I think that's a really cool feature and really handy if you're going to modify the way a service starts, or if you need to put some boundaries around it, or if you need to say, you know, what order things start in, whatever. Systemctl edit. All right, so the next cool thing is journalctl. Systemd stores the outputs of a lot of things that it runs and manages in the system journal. You might say, well, how do I read the system journal? That's where journalctl comes in handy. So journalctl all by itself will just give you the output of the system journal. I like to pass in -xe, which gives it extended output, and I think it improves the way the pager works, if I remember correctly. And now you can just kind of scroll through here and look for things that are in the worldwide, system journal. There's other ways to look at services specifically, but we're going to go into that a little bit later. All right, the next thing I like is SS, or in the old world, it was netstat. So SS will show you all of the open sockets on the system. If you do, I like the command line -tulnp, which will give you a nice summary of TCP and UDP connections. It'll show them by the numbers. It shows you what process is running on that port, things like that. There's a good way to tell what ports are open on your system, and if a port is available for use, or if there's something that's already using that port, right? It's kind of the same thing in different words. And in the same vein is netstat, or not netstat, I'm sorry, nmap. Okay, nmap is a tool that is used for network scanning. Now you might think, oh, this is like some hackery realm that we're going into. This has a really valid use case for people who are trying to either secure their own networks or simply see whether they can reach from one system to another, or if they want to see what ports are open on the system that they're currently on. Nmap, if we just like nmapped on localhost, you'll see what ports are open from localhost to localhost, which should be just about anything. The firewall doesn't usually stop anything from getting to localhost. But if you were trying to see what the server next to you had open, you could use nmap to see, is there a firewall blocking me? Is the service listening? Can I reach that thing? This is a good first layer of troubleshooting. A couple other good examples. Sorry, do you have something you want to say?
Yes. You talked about scanning the server next to you.
Yeah.
When you do that goes through your network, and there are places where nmap is forbidden to be used. And you probably want to give your network administrator team a heads up using it, because what it really does is it sends a connection request to like 1,000. And so to a lot of like intrusion detection software and stuff, that looks like an attack, which is why many places forbid using it across the network to scan other machines, is because it goes across the network and then it triggers all of their intrusion detection stuff.
Yeah. Very valid point.
That is for nmap. SS, not a problem.
Yeah, SS is for local connections. Nmap is for remote connections. And you're right. If you start using nmap en masse across your network, or even just to scan one or two hosts, it might get noticed by your information security folks. However, there are some ways to sort of limit the scope of what it's scanning, and that's exactly what I was going to show next. If you're trying to find out specifically, right, maybe you're on the web server and you need to see if you can reach the database. Instead of using, you could use the client tools for the database, but let's just use this as an example. You can use nmap to scan one specific port. Now you use the -p command for that. We're going to use 22 because I'm going to look at SSH, and we're going to look again at 127.0.0.1 only because that's the only host I can scan at the moment. I don't have another host to poke at. And this will send that same request, but only to one port, which won't look quite as nasty to your information security folks. Still, if you're going to be using nmap, heed Scott's warning. Maybe it is something you want to ask about. There's two other things I want to show you quick with nmap, and then we're going to wrap up the critical path. This is checking specifically for TCP, right? So is a TCP port open? But not all services use TCP. What if you're trying to look at UDP? If you do an nmap-s with a capital U, and then again, we'll do localhost. It's going to come back with nothing. Oh, sorry, NAMP. We're going to NAMP instead of nmap. I don't know what a NAMP is. It sounds kind of like a nap. I'd like to take a nap. Okay, and it comes back with nothing because there's no UDP sockets open on this particular host. One thing a good example of a UDP request would be DNS. So we can just do a quick nmap against the DNS server to show you what this is going to look like. So we do SU. You can still use that -p command that I showed you before. This says just look at port 53, which is where DNS would live. And I'm going to check Google's public DNS server, and maybe I'll get my server blacklisted or something for doing this. But there we go. You can see port 53 is open. I can reach it from this host. And that would tell me that, connectivity on port 53, unless it's otherwise limited through some kind of an access control list within the DNS service that is, or whatever service I'm connecting to, I should be able to connect to that port. So, did I miss any tools? Any questions about tools?
All right. So stay with us as we transition to the second half of the episode, where we're going to be going through and busting up machines and then using these tools that Nate just sent us and walked us through to diagnose what those problems are. So don't forget to mash that like and subscribe button before we transition, and we'll see you on the other side. All right, so now is the time in the show where we interact with the audience as well. So if you have questions or comments, please throw them in the chat. Also, if you're a deferred viewer, you can, of course, leave a comment, and we very often monitor and respond to comments. So, Nate, I've got this machine that I've got Apache installed on. And I decided that for our busted services, I'd actually just keep busting the same service so that we don't have to worry about the vagaries of like how services work, and can instead focus on some of those symptoms that one might see and then how one diagnoses and resolves that. So I've already got this machine or this service broken. And if we try to start the service, it doesn't work so good. And it gives us an option to look at the journalctl. So if I put in the journalctl command as suggested, this is what we get. And we actually get a couple of interesting messages through the Apache logs. Specifically, I want to direct your attention to these two lines. So one of the more common causes of services not working is, guess what? Somebody put the wrong stuff in their config file.
Somebody messed up the config.
And that's exactly what happened here. So you can see Apache is great about this. It tells me where the line number is that the syntax error is on. A lot of them will just say like what the syntax problem is, but not give you the location of the file. And then it even diagnosed it for me. That's how awesome Apache is. So it says port was replaced with listen in Apache 2.0. So maybe I was using an old thing, or I read an old document that I found at some horrible website on the internet. And let me go ahead and open up the file. Line 47. So right here is where my syntax error is telling me I have a problem. And you can see the section above says that this is for a directive called listen, and listen is what port number the service attaches to when it starts up. But instead of using the listen directive, someone put in port, which used to be the way you did it way back. And other services will use the word port to describe the port number that they want to be configured on. So it's a fairly common problem that somebody puts the wrong thing in there. All right, so listen, and let's see if we fixed it. That seems good. Let's look at the status real quick. Oh, sorry. Start status is not the right status. All right, cool. So here we are, we're active. So it's running, and we could actually probably connect our web browser to it and view the test page or whatever web content we've got in place for it. So Nate, what troubleshooting diagnosis did we do to find that problem?
Well, we asked systemd to give us the output of the journal for that particular service, which was sort of what I covered earlier, except you specifically said, show me this unit file. That's what the U after the XE was for. And Apache was pretty direct about, hey, this is where your error is. Go fix it. You fixed it, restarted the service, and up it came.
Yeah, and a lot of services on Red Hat Enterprise Linux and other Linux distros will not just use journald for their logging, but they'll also use syslog for their logging.
Yeah.
And so it turns out if we did a tail, let's see, 30 of varlog messages, looks like I had too many messages come in its place. But you can see that there's some Apache related messages in the varlog messages file too. So you don't just have journalctl, but journalctl with those arguments allows you to focus on specific messages a little bit easier. Not every service uses journald, and then things like log aggregators may prefer syslog. So syslog is still a place to look as well.
And Apache, much like many services, is one of those where some system level errors will end up in the journal or in varlog messages or maybe some other filtered out syslog controlled log file. But then other errors, once the service is running, will show up inside of the actual output from the service, which may not be in the journal or the system log. It'll be inside of wherever you've told the service to log to, right? So in Apache's case, it's usually it's usually var log httpd, depending on your system, right? There's other places that could end up.
And hopefully everyone was listening to Nate's explanation and they were in no way watching the man behind the curtain break the service in yet another and different way.
Did you forget to turn off your screen share again?
Well, we felt it would be remiss if we didn't cover this next one, but I'm not going to cover it in a ton of detail. But our troubleshooting methodology is going to kind of look the same as what we just saw. So I'm going to systemctl start Apache again. If I spell it right.
Now your system's in a cult. System cult.
Hold on, I didn't break it in the right way.
How dare you?
Yeah, maybe we could toggle off the screen share, and I'll break it real quick, and then we'll
Pay no attention to Scott breaking the system live on the air. So,
right.
Yeah, the transition from the old way of monitoring stuff through syslog and into the new world of journal, systemd journal, was definitely kind of a stark difference for me when that came with RHEL 7. So I'm sure I'm not the only one who had to learn how journal control worked or journalctl. And Apache specifically, I was doing a lot of web hosting at the time. So,
okay, now I've got it appropriately broken. Let's take a look at it here. So I'm going to do the same start, and again we get an error message, and it's the same error message because there were problems starting the service, and so we're directed to the logs to kind of look at what's going on. I need to copy and paste more, Nate.
Well, CTL is difficult to type. Every time I type it, I always think I'm getting it wrong. And systemctl, journalctl, they're just difficult commands.
All right, so here's our error message. Cannot bind to address something, port 8000. So basically, the way that many services work is they will scan your machine's configured IP addresses and then attempt to bind to the same port across all of them. And so to reference what those IP addresses are, that's where you get this kind of like wildcard IP address. So for 6, that's square brackets with 2 colons. For IPv4, that's 0.0.0.0. So our service is configured to listen on port 8000. That was what I was breaking. And then we get this error message that says permission denied. So Nate, what would we check first when we see things like permission denied?
I mean, I don't want to go right to the thing I know is the answer, but I don't know what else I would tell you. So this basically means that something on the system has prevented Apache from attaching to that particular port. And there's only a couple things that could do that. One would be, I guess, if you were running Apache. No, I guess even still, if you're running Apache as a non-privileged user, it would still be able to connect to 8000 because it's a non-privileged port. But it's probably SELinux because I know you're running it as root because I don't think you changed that. And you're on a non-privileged port, so it shouldn't care. So yeah, SELinux. Good old SELinux. Just turn that stuff off.
And no, don't turn that stuff off.
Don't turn that stuff off.
And when we look in varlog messages, we actually see more explicitly that it's SELinux that's blocking it, right? Because this machine is running set troubleshoot D. And so when the SELinux violation occurs, it very helpfully says, oh, by the way, this is what you could do to fix it. But if you read the messaging here, it says the SELinux is preventing that service from binding to port 8000. And then it tells you how one could fix it if they wanted to.
Right.
But I don't want to go into a lot of details with SELinux. But attaching to non-standard ports for services and SELinux tends to be a problem because SELinux has like a list of ports it expects to find certain services on.
Right.
You vary outside of that list, then all of a sudden, like it's going to stop your daemon from attaching to that port number. And so instead of turning it off, instead, if you are interested in more this realm of troubleshooting, we have 2 previous episodes that we covered in depth on SELinux. One is kind of a basic thing on SELinux and how it works and how you can do things like add ports into your SELinux port mapping. The other one is a little bit deeper into SELinux troubleshooting, which includes making updated policies so that when you reboot your machine, that all of the rules that you've put into effect are still there on the machine. So I would refer you to those 2 previous versions of Into the Terminal if you want to go further. But to fix this one just real quick, SE manage -p, man, I think it's -a. I'm going by from memory, so of course it's not going to work. All right, SE manage port. Still not. All right, I'll leave it be because I'm going from memory and that's never gonna work.
This
but
reminds me of a previous episode. Goes by the name of sudo.
invoke the forbidden episode.
The forbidden episode.
Yeah. So it could have also been that we typoed that, right? We typed 80, but we ended up hitting some stray characters in VI and it ended up being 8000. But notice that if we change it back to port 80, man, having a rough day today, Nate.
Start goes first.
Works just fine, right? So now we can systemctl status HTTPD, right? And it's active and running. So trying to bind to a non-standard port can cause problems, maybe through SELinux, maybe because you typoed the thing and that's what's triggering SELinux. But that would be something to take a listen or a look at as well.
And you might wonder, like, why does SELinux care if Apache is running on 80 versus some other port? Like, why is that a big deal? Why do I have to be limited in that way? And that's because you've got a server that's running or that has Apache installed, or maybe it didn't have it installed, and an attacker hops into your machine and has shell, and they want to try to exfiltrate stuff from your machine. They might try to start up Apache on a port that you aren't looking for and pull that data out through there, right? So this would prevent them from doing that. or help prevent them from doing that. One more layer.
All right. So I did want to just cover off on without SELinux, we can also have port problems. So notice that I temporarily disabled SELinux. And we're going to change it to listen to another port. And now when I do let's make sure it's stopped with the old config, and then we're going to start it back up with the updated wrong config. Right? Again, it's broken. And if we look at the journalctl, we get this one. Now notice that the error message here is a little bit different. Before, when we saw the SELinux functionality stopping the binding, it said permission denied. Now it says address already in use.
Totally different error.
Yeah, something else is attached to port 22, and that's why it's not allowed to attach to it. And so what might be interesting is to know what's listening on port 22. And so one of the other tools that Nate showed us earlier was socket status. So if we do an ss tupn, and we're just going to grep that for port 22. All right, we're told who is bound to port 22. So the reason that Apache can't bind to port 22 is because SSHD is attached to port 22. And while port 22 is a pretty well-known port, and I'm sure many of our viewers, when they saw me change it to port 22, was like, oh, that's not going to work. That's going to flip with SSH. Realized that could have been any other port that some other service was attached to. So you use tools like an SS command to see what's out there, what's listening on that port, so that you don't generate a conflict where your service is trying to attach something that's already attached to. All right. Another variation that's becoming increasingly common on port problems is containerization of services. All right. So before the show, or maybe even during the first part of the show, while Nate was telling us about the tools that we were doing, I was building this enterprise Linux web server container, right, called EL-HTTPD1. And I built it as a non-privileged user. And it's a better security practice to attach services or to run containerized services as unprivileged users. That way, if something were to go crazy and it breaks out of its containerized environment, it's running around on the system as an unprivileged user, as opposed to running around on the system as root with all the rights and privileges of root. So I created this Apache container as the RHEL unprivileged user account, and I can run it with Podman. And so we can look something like this. Let me try one more time. All right. So we're going to do a Podman run. We're going to run it in a disconnected mode. So it's got daemons. It'll just run out there on its own. I'm going to give this port mapping, and here's the name of the container that I want to run. All right. And this is what we get. So we can't run that container because as an unprivileged user, you are not allowed to attach processes to port 80. And so that -p syntax there basically says, I want the system's port 80 to direct traffic to my container. And then on my container, I want it to direct traffic to port 80 running inside my container. So inside the container, I have an Apache daemon running, and it's attached to port 80, and the host, container host, is actually directing traffic from one port to port 80 on the container. And so one way we can address this is say, okay, we're going to attach to port 8080 on the host, right? So we're attached to a non-privileged port, which is anything over port number 1024. And unprivileged users are allowed to attach to port numbers greater than 1024. So I attach incoming traffic to the host system's port 8080, redirects the traffic to my container's port 80, and that's how I get traffic into the machine. And so I may then have to go to things like firewall rules and other stuff to make sure that traffic is directed to this port number as it hits the machine. And so you still require a little bit of root intervention to make that that adjustment. Alternatively,
I sometimes wonder how important the privileged versus non-privileged ports thing is anymore. With the advent of SELinux and just in general, how many services run on what you'd consider non-privileged ports anyway? I don't know if anybody's thinking hard about that question, but I wonder every time I have to do this.
yeah, and so that's actually where I was going is let's see. Nope. Nope. There it is. So in proc sys net IPv4 IP unprivileged port start. So the reason that unprivileged services can't attach to any ports below 1024 is because there's this setting that says they're not allowed to. So instead, if I do this, basically I'm saying privileged ports are from port 1 to 79. And anything above port 79, regular people can attach to. So if I again become root or the RHEL user, and I run that podman command to start up my container and bind to container hosts port 80, directs to containers port 80. Remember last time that failed. But now it doesn't. Oh, except yeah, except now it doesn't. So right here, I'm running my my container, and you can see that it's attached to all the IP addresses of the host port 80, and it directs to port 80 inside my container.
Right.
So to Nate's point, like, what are we protecting from running as root? And there are valid reasons why you would not want to do that, right? Maybe you want to make sure that if somebody connects to port 80, you know that it is a system service running on the container host, and therefore it can't be redirected to anyone's web server running a container on the host. But that's one way to address people running services on the host that need to address or be connected to privileged ports, is to change what those privileged ports are in the system configuration. The change that I made to procsys is not persistent. So if we were to reboot the machine, it would go back to port 1 through 1024 would be privileged. So you would have to persist it using either a mechanism called syscontrol to make sure that it's persists between reboots, or you could use something like a tuned profile to make sure that change was persistent between reboots. But that's another option. All right, let me toggle off the screen for just a moment. And I have one last break to show folks.
So now's a good moment to remind folks we have a Discord community. If you aren't already in there, there's a QR code at the top of the screen. You can scan that, get the invite, which should work, although we've heard some folks say it doesn't, but every time that we test it, it does. So if it doesn't, I guess reach out somehow and we'll figure out why you can't get in. But me and Eric hang out in there. A couple other viewers hang out in there. Yeah, we're trying to build a nice community around the show. So hop in there. That and the RHEL Presents folks. Anybody who likes our content, we'd love to hear from you that way. Interact a little more.
Uh-oh, Nate. I may have broken my machine in a new and interesting way.
Did you break it in the way you did not intend?
Yes, I broke it in a way I did not intend.
Well, how about while you fiddle with that, I'll talk about how to enable services at boot. What do you think?
Yes, let's do that.
All right. Okay, so you've got a new service installed. In my case, I installed MariaDB, same service that I used in my example during the critical path. But now you have to make sure that it starts at boot. So first of all, obviously, I'm not going to add the dot service. If you leave off the dot service, it'll make an intelligent decision as to what it is that you're trying to call. In this case, it defaulted to the dot service, but you can call things directly. There's sockets, there's services, there's timers, there's all kinds of stuff. Anyway, you can see here that it says that it is inactive, right? You see where it says active, inactive, dead. Poor MariaDB is dead. Long live MariaDB. And it tells me what unit file it called for. And to see this disabled right here, that means that it will not start at boot, right? Now we can still start it. Okay, and what this will do is it'll start up the service. And then if we look at the status again, it's going to say, hey, it's active and running. Yay. But it still says disabled. So now if I were to reboot this machine, which I'm not going to do now because that would take a few minutes to reboot and it's just a waste of time. But trust me, if I were to reboot this machine, it won't come back up at boot. So let's stop it again quick because I wanted to show you one other command that's actually really nice. So there's a command called enable, systemctl enable, which basically takes it from that disabled state to a enabled state, which tells it, yes, this thing should start at boot. Now, you might think that disable and enable means the service is disabled, as in you can't start it. That's not what it means. It means that it is enabled at boot versus not enabled at boot. So systemctl. See, people who are telling me about tab auto-completion, look, system, if I hit tab right now, there's like 100 different things that start with system. So don't tell me tab completion is the answer. Systemctl enable MariaDB -- now is the extra thing that I wanted to show you. So now says don't just enable it, because if I just did systemctl enable MariaDB, and then if I do the status again, it says, notice it's still inactive, but it's enabled, which means if I were to reboot the server, it'll come up when I boot it, but it does not, it doesn't start it when I run the command. So now I would have to do a systemctl start, which means I have to do two commands. Now let me just disable it again. And you can see in the status again, now it's disabled. If I do the same enable command, but I add -- now, it'll tell systemd not only to enable it at boot, but also start it right now, right? So now if I, and you can see there's actually, the way it knows to start them or not is there's just symbolic links that are placed inside of the proper directory structure within systemd. That tells it these are the services that I want you to start at boot time, which you might recall is very similar to the way it worked in the old init system, right? There were you put a link to the script files inside of the different run levels you wanted them to run in. Well, this is same concepts, except systemd uses targets instead of run levels, and it uses different types of service files. But I digress. If I do status again on MariaDB, you'll see that not only now is it active, as in it's running, it's also enabled for boot. So that's a good trick, especially if you're trying to automate this stuff. If you want it to start and enable the service right during your automation, you can add the -- now flag to the enable. If you do not want it to start immediately, you just don't use the -- now flag, and there you go. Okay. Nate is not dominating systemctl. I don't know what that means, but okay. Okay. And the other thing I was going to talk about was the journal, but we kind of talked about the journal pretty in depth already. I don't know what else to cover there. So, are you ready for your other demo now, Scott?
Yes, in a very oxymoronic way, I'm going to say I have a working broken machine.
I have a working broken machine. Good.
All right. So this is one that I have encountered occasionally. So I'm going to show you what it looks like, and we'll troubleshoot it. But this is kind of one of those, like, I've done all the normal things, and I still can't figure it out. Let me check this last thing. So if I systemctl start Apache, we get this error message, right? No surprise, because I said that I had a broken machine. And here we go. Oh, we're back to line 47. We saw this earlier. Well, let me take a look at this.
Yeah. Port must be specified. Oh, this time you forgot the port. Well, go in there and specify a port, Scott. Come on.
All right, I'll do it. Just
you got to tell it a port. If you don't tell it a port, how's it know where to start?
All right, so we're going to go down to listen. Right, there you go. Nate, it looks like I specified the port number.
Yeah. So, I mean, my very trained eyes indicate that there's 2 spaces between listen and 80, but I don't think that HTTPD cares that much about white space.
Okay, it doesn't, but you know what? I'll just delete one of those spaces. There you go.
Okay. You think that'll fix it?
I don't know.
I mean, you know whether it's going to fix it or not, but I think it should. Oh.
Nope. Sorry, not fixed.
Well, what's the journal say now? Is it a different error?
Good question. Yep, line 47.
Oh, wait. What's that? Listen /XA080? That's not what was in there.
That's weird. Let's look at it again.
That is weird. That was clearly a space.
Right, so here we are. Listen 80. I don't know what's going on here.
That's a strange one. So personally, what I would just do is nuke the whole line and retype it. But I think you've got something else up your sleeve here.
Yeah. So what I'm going to do is I'm going to cat that file. So we know what the cat command does. It just concatenates a file to the screen. But the VET options, actually, it's really only one of those matters. But I like spelling it as VET because I can remember it easier because you take the cat to the vet.
You're taking the Apache config to the vet.
That's right. What it is, it will show you unprintable characters. So when we look down at listen, this is like after running it through cat vet. So that thing that we thought was a space is actually not a space. It's this meta dash space in a thing.
That's interesting. I don't even know what you would use to make that, but okay.
It's incredibly difficult but it doesn't always have to be incredibly difficult, and it's kind of weird. My first time encountering this was when I was writing code as an undergrad, and I don't know whether it was like a hiccup in my connection to the machine on the network or what, but a stray control character got shoved into my source code, and I kept getting errors from the compiler about bad syntax on a specific line, not unlike what we just saw Apache complaining about. And I actually did delete the line and put it back in by hand and still no. But it turns out it was at the end of the line. And when I deleted it, I literally used the character deletion to like remove all the content of the line, not recognizing that I had this extra space, what appeared to me to be a space at the end, that was actually this weird control character. So let me go back into the file and we'll edit that out. So we'll remove that and put in space. Oops, that's not what I wanted. Let's do our systemctl again. Right now it starts up just fine. So control characters, or actually a variety of unprintable characters, can sometimes make their way into your files. Now, probably the most common way to get this is something like you edited the file on a Windows machine, or you use the integrated into GitHub editor for making a quick change to a thing. Well, it turns out both those editors use carriage return and line feed characters to indicate the end of a line. Which, if we were to look at it with catvet, would be displayed as a control M is the carriage return, and then there's another character which is a $ for the new line character. And as I was experimenting around those, when we talked about it on Monday, I was like, "Oh, I got this," and that was my plan. I was going to Unix to DOS a file and break my stuff. And it turns out that a lot of services and applications on Linux boxes now are quite happy with carriage return line feed files. So that didn't work out in my favor. So I had to go and like find another unprintable character to shove into this file to create this problem.
I tell you what, Scott, they keep taking all the sharp edges off of everything anymore.
I know. Why are things easy to use and forgiving?
Yeah.
But so there's a tool called DOS to Unix, and I see that Vincent mentioned in the chat. So that will take a Windows formatted file that has control M's and returns in it, and will convert it over to a Unix system. And it goes the other way too. So let me, in my terminal, I'll go ahead and DNF install the DOS to Unix package. And it's to do this this conversion to return or to remove those extra characters. So if I do a Unix to DOS on this file, see here at the end of every line is this control M new line. That's what files edited on Windows or like GitHub editor will add. And so to get rid of it, you just convert the file using DOS screen, DOS to Unix on that file that has that format, and it will replace it. Right. And now when I catvet, I just have new line characters.
Right.
I don't have that control M anymore. But DOS to Unix doesn't care about those other weird ones that are that we had in our file earlier that looked like a space because the terminal could not represent it with a character. And that's why it just got shown as a white space character. For that, you need to use something like cat-v. There's another super old tool called OD that can also do that. It looks like this. Sorry, OD-C.
I see billboards all over the place about OD. I think that's a different OD though.
So what this is doing is it's actually showing you every 8 bits, or I should say every character. Yeah, every 8 bits. So when I originally ran it, it was just all numbers because they're showing it to me in octal. So OD-C shows me the character value for each 8 bits. And this
is super easy to read. I'm glad you showed me this tool.
Right. That's why you want to we're all coming full circle. Use cat-vet because then you can actually see the file as it exists in a much more sane way. But
And
back in
I
the
don't
old
remember them off of
that.
I don't remember them off the top of my head, but I think that both Vim and Emacs have commands that will show you hidden characters within the editor as well. So that could be helpful in some cases.
Could be, and it turns out that less actually does some stuff with a wider character set than VI uses. So while we opened that file in VI and we couldn't see it because it was represented by white space, when I looked at that file that was mangled with less, it actually had a weird blob of characters in there that that it represented. In fact, I could probably just pull that. Let me see here. Yeah. So you can see here is my original file I was using, and it has it in there. And if I do a less, right, it shows it as this weird highlighted character something something. But it can't find every character that way. So cat-vet is still the unarguable king of showing unprintable characters in a file. And I usually combine it with less so I can see it one screen full at a time as I'm looking through it. All right. So when all else fails, when you're like surely sure that everything is correct, that's a weird one that occasionally does happen, and you'll get to enjoy taking your cat to the vet with the
Yeah.
file.
Good stuff.
All right. So that kind of runs us off the end of our prepared remarks. I saw a couple things in the chat earlier in the episode. Somebody asked about journal D being persistent. And I know that at one point journal D was not persistent. I haven't checked RHEL 9 to see if it's persistent on RHEL 9, but it was not persistent by default on RHEL 7.
Memory tells me that it's not persistent on RHEL 9, but I would have to go check. I'm not certain. I know there is an option that you can turn on that will make it persistent. And there's also ways to get it to log to like a third party, right? So you have it stored. But yeah, I think, well, I don't want to say much more on it because I'm not certain, but I think it's not persistent on RHEL 9.
Yeah, and I saw a Reddit thread a while back where somebody was expressing frustration that it was not sent by default. And it's like, well, one of the reasons why it's not is because we still use syslog, because syslog has really good integration with other log aggregators like Splunk and other stuff. And if we persist the journal log, we are essentially logging every message twice, once the journal log and once to the syslog system. So we chose to only log it once by using syslog and leaving journal ephemeral. And if that's not what you want, you can certainly persist journal. But along with that comes things like, how are you managing those additional logs that are now perpetually growing because they're persistent on your machine, right? So if you're going to do that, then make sure that you account for it with things like log rotates and other stuff. And then if you wanted to make it persistent by default, you can just like throw it in your Kickstart file or something else that will run the configuration to persist it.
And we've talked a whole bunch about syslog, and we haven't really delved into it. I don't intend to delve into it, but just if you're not familiar with syslog, there is a daemon on your system called rsyslog, which will take journal or log entries from the logging. What's the word I'm looking for? There's like a subsystem, a logging subsystem, and it'll do what you tell it to do with them. We've told it to write to files, but you can tell it to do lots of other things. So it's something that you can keep in mind. You can have it write to a third party. You can have it write to a different rsyslog server. There's lots of different ways to deal with those logs. Normally, they're written to those files inside of rlog. So just something to know about.
All right. I didn't see any other comments or questions. Nate, did you see any that were insightful or something that we should cover before we sign off?
I don't think I did. There was a little bit of snark, a little bit of commentary, a little bit of fun. I didn't see much in the way of questions. So if we missed your questions, please feel free to leave them as a comment after we're done, and we'll get back to you with a comment afterward.
Right on. All right. So what's coming up? Next week, we are not going to be doing it into the terminal because Red Hat has seen fit to give us a company holiday next week. So thank you, Red Hat. But we will be back the week after that with into the terminal. Also, not this upcoming week, but the week after, RHEL Presents is going to be doing a interview with Ask Noah of the Ask Noah show. So that should be interesting about Linux and Linux community. And then next week, we're getting another installment of our new satellite mini-series with our friends Richard Rios, who you will see in our Into the Terminal chat here, as well as Eric Hicks, our fastidious producer. So
fastidious.
That's right. So tune in to their satellite mini-series. Next episode is going to be on adding systems and packages to your satellite. So they covered this past week installing and kind of an overview of what Red Hat Satellite is and provides. So you can catch up on the episode if you missed it. And then next week, they'll be covering adding systems and packages. So until next time, thank you for watching In the Terminal. See y'all later.
Yep. Have a great one, folks.